of if there are aspects of the class that you don't understand. Next week, Monday, in the afternoon or evening, you are going to write your first test. Will it be online? Will it be face-to-face? That will be confirmed by Wednesday. But likely it will be online, likely. So it is more probable for you to write it online. But if there's a possibility for you to write the test face-to-face, then we'll go for it. Okay, so you have the floor. Is there any question, any concern with respect to the module? If no question, at least the class rep should say something.
Yes, sir. So we'll confirm that the test will either be online or face-to-face on Wednesday. And then the other question was, should the assignment be typed or handwritten?
That's a nice question. I like it. Obviously, for me, if you type, that would be the best thing.
So he's saying we'll get more marks.
If it is handwritten, anyway, obviously there are you know that there are handwriting that you can read properly, and the layout and all that. So it has an impact when you don't type your work. I will encourage you to type because at the same time you are learning. There is when it comes to equation, and I will even encourage you from now. I did that a few years ago, but since then I haven't done that with the student. At the same time, it's a learning process for most of you. For those who will be pursuing after those of you who will be doing honors, you'll be writing mini thesis and the like. So you need to learn LaTeX. It's really fast in compared to Word. When you use Microsoft Word equations, right, it's a bit slow. But if you use LaTeX, it's really fast. So this is an opportunity for you to learn LaTeX. So please just Google, YouTube, go to YouTube and type LaTeX tutorial. LaTeX, the package is free, everything is free. And you just type, you don't select equation here, you type, there are rules. If you want to write integral or sum or whatsoever, you just type a sentence, and when you run the program, you convert it into a sum, and it's really beautiful. Look at my notes. You can see the type of the structure of the equation or the style of the equation, completely different when you use your Microsoft Word. So my note, I use LaTeX. It's easy to learn, particularly at your level. You don't need to know that much. Maximum 2-3 days, you are done.
Okay.
The basic
Thank you, sir. So it's optional. Is that what sir's answer is?
It is optional, yes, but I encourage people to type.
Okay, sir.
If you write and submit, I will not reject it, but I will not appreciate that anyway.
Okay, thank you, sir.
Okay.
Doctor?
Yes.
So me, I just if doctor can, if possible, share the the zonal that you always the zonal PDF that you write in class.
Okay.
Yeah.
So you mean you want why is it not showing? This is what you want?
Yes, doctor.
Why do you want my nose, guy? Okay, I will Okay, yeah. Remind me, send me an email if you don't see it by what time? By 2. If you don't see it by 2, send me an email to remind me. Yeah, I will convert this into a PDF file. I will upload it here on the e-learning platform. There's no problem. I can do that. If
Okay,
you think
thank
that,
you, doctor.
if you think that getting it will make you pass, then no problem. Because don't go and cry tomorrow. I asked him to send this one. If he sent it, I will have passed. Because he didn't send, that's why I'm failing. Okay, I will send it so that you will not complain.
Okay, thank you.
Yes, I'm listening to you guys. You have an opportunity to talk. Wow. Jonas, you are there like a top model. Yeah, you have the floor. Can you say something?
Hello.
Yes.
Okay, let me saying something, sir.
I beg your pardon?
I'm saying let me saying something, sir.
Say it.
No, I have nothing to say, sir.
Yeah, that's something already.
Yes.
Okay. Are you a top model?
No, not even.
So
Not at all.
you are not intending to be a top model. You don't participate to those fashion parades. Oh, okay.
No, I don't participate.
All right. Okay. Great. Simeon, Kashupi, Freed, Aaron Freed.
Sir,
Freed, say something. Ask a question.
sir, you
That
answered my questions already.
No, but the one that will make you get 90 or 100% during the test. Ask that particular question.
I don't have it today. I'll ask you on Friday maybe or Wednesday.
Really?
So far today, everything is okay. Yeah.
Okay. All right. Okay, no question.
Yeah. Because I'm not
Uh,
even far with studying. I'm kind of behind. Yeah. I'm just a championship say whatever. Yeah. I didn't go far yet.
the test is next weekend. Next week.
Uh,
Okay. Is there any question respect to the first tutorial?
yeah, are
Tutorial
you there?
one? Yeah. I'm listening.
Yeah, the network is tripping.
Who is talking now? Any question respect to tutorial one? You have to make sure that you do all the questions in that tutorial sheet. Make sure that you do all of them and you understand them nicely. All. Because remember, it covers everything up to the Fourier series. You should be able to do all those problems without any difficulties. Is it clear? Simeon, you're then looking at me like this as if you want to swallow me. Simeon, ask a question. Simeon.
So
Ask a question. It is free of charge. You will not pay for asking questions.
I don't have a question right now, sir.
You don't have a question?
For now.
Oh, so you have it for tomorrow?
Most likely.
Are you a politician?
No, sir.
So you are trying to manipulate the English language?
No, sir. I was busy checking out the tutorial.
Errand free. You think that you hide. You cannot hide.
I'm not hiding, doctor.
That's what I'm saying, that you cannot hide. It's even impossible.
I have no question.
Oh, you have answers. Eh? Can I ask you a question now? Okay, so you have answers, eh?
No, sir. Probably.
What do you have?
I'm just here to attend class, sir.
Sorry?
I'm just here to attend class. No questions,
Yes,
sir.
it's part of the class. Don't say that you are an observer. If you're attending classes, as you are saying, you have to ask questions, you have to say something. You are not an observer. Attending class means that you are an active participant. Active means that you act. Active, action. It's not observer, because an observer is like a statue. Because I don't want to add extra something. Eh? I could continue with my class, but at a certain time you stop to try to evaluate the student to see or to find out if you look eyes to eyes with your student, if you are the same page, if they grasp the concepts. That's what I'm trying to do now. Try to check, because I don't want to be surprised on Monday during the test. Oh, sir, that test, ooh, ooh, I thought I understood, sir. I miss here. Oh, start telling stories. Oh no, next time, sir. Ooh, I promise 100%. Promise. So you want to tell me that everything is clear, nice, clear like crystal, clear. Is that what you're trying to tell me? Camelo, you're a regular student, so what don't you understand in this class? Which concept? Which particular concept? It's true that you have the videos, you can watch and watch and watch, you have the impression, okay, I understand. Try the problem. Oh, I hope that this thing will not go off. I hope it will not go off. So if you don't see me for a while, it means that, because I can realize. Okay, I fix it. It was okay. Yeah, it's okay. It was indicating that the battery is getting lower. Okay, but it's fine. But one never knows, huh? But yeah, I can see the battery is full. I can see it from there when I show it. I don't just want you to realize that you cannot hear me. Okay, Camelo, I think you are the one who asked the question. I asked the question to Camelo. So I was saying that, For you to test whether you understand is to do the problems. That is where you'll be able to know whether you understand or not. It's not by reading, watching the videos. Oh, yes, it's well explained. If you don't take your pen and tackle problems, try to solve them, then you assess your actual level. That's where you will know, no, here I have a problem, and then I can ask. How many of you have you done most of the problem? If you're one of them, indicate. Johannes, how many questions have you tackled so far? Kashupi?
Sir.
Madam?
Mm-hmm.
You're not saying anything, I'm listening.
So what is your question again?
Oh, your question is a nice question.
Sir, are you asking how many questions I did in the tutorial?
So you heard my question and you were pretending.
No, I'm just trying to confirm. Okay, sir, I did.
You confirm, you want to be a confirmation of what? You heard my question. It is so clear. You don't need an interpretation, or you don't need a revelation to understand that question. It is so clear, like crystal.
Okay, sir,
like still water. Not like water from a certain area. I don't want to call the name of the area. Still water, clear like crystal.
Yeah, I did 3 questions from the tutorial, if I'm not mistaken. Yeah, and then the others I did not.
Only 3.
Yeah, but the others I did not do from the tutorial that you gave us this time. I did from a different what tutorial, those years tutorial. So I'm doing questions from different question papers. That's why I only did a few in the tutorial that you gave us the other time.
Okay.
Yeah, but yeah, I did like that. I did much work. I'm not only doing one tutorials, I'm doing different questions from different question papers. Yeah, like that. But don't worry, I'll finish it. I'll finish it.
No, you're not at the court. Don't worry. Nobody will condemn you. You will not be shot. Nobody will. Don't freak out. Don't feel guilty. Not a problem. I don't have a gun to shoot you, so don't freak out. Relax. Simeon, you're just looking at me. What have you done so far, Simeon? Camelo, I'm still waiting. I asked you a question. You haven't said anything. Yes, Simeon. How many problems?
Exercise 1.
Now I have a gun for you because if you play, I will shoot you.
See, I'm looking at I'm answering your question. I did the whole of, most of exercise 1, except the last question for exercise 1 and exercise 2. And which one else? Yeah, I didn't touch exercise 3 and 4.
So you said you did exercise 1, except the last one, meaning except 5, but you did the rest.
Yes, sir.
And why didn't you do this one? Okay.
I'm,
You did also exercise 2.
yes, sir.
All of them, 1, 2, 3.
Except the last one.
What is your problem with the last ones? Oh, you have decided that you don't wish to touch the last question. Okay, exercise 3. Have you done everything except the last one, obviously? Exercise 3, let me look at the last question. Okay, except the last one. Surely you didn't do that one, except that one also. Let's look at the rest. Have you done this one?
Which one, sir?
This one, 1, 5.
No.
But I explained this in class recently. Why haven't you touched this one? Okay, 4. I did the 4 in class. Have you done that on your own? To see that this will be the range of K, have you done that?
No, sir, I didn't touch exercise 3 and
Oh, maybe
4.
you wanted a tip, or I mean, when I say tip, you wanted maybe a prize, a gift, or something, an incentive, in terms of
No, sir.
maybe
I'm
a piece of cake, or I don't know what, invitation to KFC to eat
no
junk
shombo
food.
chicken.
Or
Chicken,
you want to be, you want the motivation. What do you want to eat? Bumbo chicken so that you can
yes.
do it.
Sir,
Because I
I
recall
didn't start with foreign
when I
series
was still
yet.
in primary school. Was it in primary school, man? I remember when the teacher would ask me to read, I would refuse. Because at that time we had a classmate. The father had a bakery. She would come with some cake and give to the teacher. She would sit there and eat in front of us. When she said, "I refuse," I said, "I will not eat." I remember she said, "Okay, I will give you the cake." I started reading, but she didn't give me the cake. And that's true. And it's a true story. I'm not making it. True. I remember it because that was a long time ago. So maybe you also want something, even though I'm not eating it. At least if I was eating something, you could have said, "No, he's eating in front of us. He's not giving us." I will not also do the present. I could have understood because that's what I did with my teacher then. I refused. She said, "I'm not reading." I refused. She said, "Okay, I will give you." I said, I started reading. True story, eh? True story. So, Simeon, so you want an incentive? Cake? What do you want? Bumbo chicken? Okay. What do you want to do this today? So that tomorrow when I ask the question, you say that I did it. What do you need? Simeon, I'm asking you the question. So you don't need any incentive, you do it, right?
So once I start with foreign series, I'll do this.
You do it.
Yes.
That's good. That's good. That is my goal. That's good. That's great. Camelo, I ask you a question. Okay, now let me give you a problem. Oh, what is this thing of Fourier series? Oh, what is that? Okay, let me give you a problem now. I want you to do that problem. Oh, I think I asked a question in one of the tests. Huh? Don't always expect me to give a past question. Huh? Anything can be asked. I can give you any function and ask you to perform the Fourier series. That's why I say you have to understand. You have to be able. Okay, if I give you the function sine, is it sine x? Because sine x you have. Okay, let me give you a problem, and I want you to do that problem. Oh, good. I want you. I will give you a function. A function. I will give you a function. Okay, I will take. Okay, let's do that together. I will design the question in front of you. So let us do this. So I'm going to do this. I'll give you given. I'll say example exercise. Okay, exercise or example. Okay, so I want you to understand that a question can be formulated in various manners. It's up to you to understand what it means. Okay, I can take a function which is not. Yeah, I can define the function from. Anyway, example or exercise. Example exercise. Okay, let me look at this. A function can be structurally odd or even. When I say structurally, I mean the structure of the function itself says that this function, but it can be made an odd or even function by conception or by construction. Am I communicating? Do you understand what I'm trying to say? If you don't understand, tell me before it's too late. Do you all understand? Camelo, I asked you a question. You haven't said anything.
What did you ask, doctor?
You get a Nobel Prize for asking that question. So you were sleeping. Okay, example. Oh, what is happening with this? So example. I repeat again, this is what I said, that a function can be structurally odd or even, or it can be made odd or even by construction or by design. Do you understand that? It is simple. For instance, if I write the function like this, okay, this is just an example. If I take this function, if I take this function f of x equal to, you remember the function, this function? I think that, yeah, this function, this is what we used last time. There was this one. Okay, if I do this for x in this interval, negative pi, pi, you can see that this function is an even function. Even if I don't say it, you can see that already structurally, this is an even function. Because if you take x here, the negate of that is still in the interval negative pi, pi. You agree with me? And f of negative x is equal to absolute value of negative x, which is absolute value of x, which is f of x, for any x here. So that even if after this are extended periodically, it will still be an even function. If you draw this function in this interval, you see that you have this one, and then you flip it about the y-axis. That is symmetry. About the y-axis, you get the other one. So it's an even function. Now you can take that and translate throughout a various interval of length 2 pi. It gives you an even function throughout. Right. But I can construct a function which is structurally not even nor odd. I can design it in such a way that it becomes even or odd. That is by construction. I can just say that given this function, I can say that this is an odd function over this interval and extended periodical whatsoever. When I say the function is odd, it means that you have to use this theorem, f odd, because the statement of the problem tells you already that the function is odd. Right? But structurally, if you look at the structure, it is not. Is that clear? I can give you an example. I can give you an example. But that's why I want you to understand this concept clearly. I'm saying it because, was it last year? I gave a function and I said that the function was an odd function, meaning that you consider it to be constructed as an odd function. Even though the function itself, let's say for instance the sine function. When you look at the sine function, the sine function structurally, or the cosine function, but I can construct it and say that no, I want it to be like this and impose that condition. But you have to take that into account. Is that okay? Are we together? Okay, let me give you an example. I can give you this function, f of x is equal to 1, for instance. I can say this is a function, example, given the function. Okay, example 1. Given the 2 pi periodic function, periodic, and I can even say an odd function. F of x equal to 1. For x, for instance, in the interval 0 pi. Find the Fourier series expansion, or Fourier series, or this Fourier expansion of f. Okay, now you look at the function f of x. How can this function be structurally odd or even? It's not. So if you just take it throughout the real line, if you look at this, it cannot be. But by construction, I've imposed that this function becomes an odd function by construction. What does that mean? It means that whatever I have here, if I take the negative of it over the interval, this is 0 pi, so I can take it over the interval negative pi 0. Take it, then it becomes negative 1. Because you are told that the function is odd. So if you want to represent this for the function to be to satisfy this condition, you see that now I'm constructing the function to be an odd function. Now it becomes like construction is no longer by, it's not structurally, that's a term that I'm using. So structurally or intrinsically, right, the function is not. But because it's a periodic function, by construction, of course, because we are dealing with periodic function, the period is 2 pi, so I need to know the function over an interval of length 2 pi before I can translate throughout. But here we can see that it's defined only on an interval of length pi. Now, because it's an odd function, I can find the other part of the function, right? Of course, and we know the function has to be piecewise continuous. Don't forget that. Okay, it has to be piecewise continuous. Already, it's continuous over this interval, right? Okay, so this is what I would do. I can do this. So I assume that this is my 0 pi, negative pi, this one looks longer. It looks a bit longer. I don't know. Yeah, maybe. Yeah, anyway, it's better like this. And this is 0. Yeah, here, this is 0. Right. Okay, now I will use this as 0, and I will put 1 here. For good scaling, I will assume that this is 1. So this is the function. From 0 to pi, the function takes the value 1. Anyway, something like this. All right, now, on the other hand, now if I take the symmetry with respect to this one, on this other part here, I can make the function like this. And here we have -1. This is an example. Obviously, even though it does not reflect exactly, but this is our function. Now you can see. Now I have my interval from here to there. This is my interval -pi, pi. You see, -pi, pi. This is an interval of 1 to pi. Now I can copy this, translate it throughout. I obtain my periodic function, which will be an odd function, because by construction I impose it. I impose that the function should be periodic. I mean, yeah, periodic and of period 2 pi, and also an odd function. I can do that. I'm free to do it. Okay, so this is the first example. I can use this. I can also define another function, g. I can define a second function, g. I can define another function that I will call g. Similarly, I can say here g of x equal, for instance, to x squared for x in the interval 0 pi. I decided it's also odd, an odd function. I also want the Fourier expansion of g. Now for g, what will happen? But if you look at this function, throughout the number line, throughout R, this function is, if you look at that function, x squared, throughout the number line, it's an even function. But I can make this function to be x squared from 0 to pi, right? And then from -pi to pi, I take the symmetry about 0. Then I will obtain an odd function from this function. So you have to be very careful, and I will show you how to do that. So this is my function from here to there. So if I take that, it will be, of course, pi square will be somewhere here. It will be really large. Eh? But I will assume that my pi square is somewhere here. So this is pi square, and maybe -pi square here, just for the purpose of illustration. Okay, so pi square will be somewhere here. Obviously, it's too far. Eh? I'm just assuming. Okay, so the function will go like this. You see, now symmetry about 0 will make my function like this. So you see that from this function, I fabricated and manufactured a function that is now an odd function. And this is my odd function that I fabricated from this. So you have to be very careful from the statement of a problem. Now, if I do that for this particular case, now let me focus on g instead of f, right? Let me focus on this. Because with this f, the function becomes easy. Yeah? The Fourier expansion of this is really easy. Right? Because it's an odd function, I know already that my a case will be odd 0. By construction, I don't need to compute. I don't need, because the statement tells me that it's an odd function. If you compute, substituting this, it will not give you 0. Because structurally, the function is not an odd function. But by construction, you are making this to be an odd function. So if you take this function and compute the B, A case, it will give you non-zero. Because structurally, f of x equal to 1 is not an odd function. But by construction, the way I'm constructing it now, the way I constructed it, and the way I represent it, it is now an odd function. So, what I will say for these two cases, by the statement, my function is odd. By construction, but not structurally. If I look at the expression, structurally, if I substitute into my A case, it will not give me 0. But the statement tells me already that we are constructing it from this expression to make it an odd function. So, by construction, all my A case will be set to 0. Otherwise, it will not work. Okay, I hope it's clear, because what I'm trying to convey an important information, and I want you to understand that very clearly. Please, if you don't get it, watch the video again. And go back to the video. What I'm saying is very, very, very important. Okay, so from the statement, I repeat again, f, or respectively g, odd function implies that their A case are all zeros. All the A cases are 0. Of course, I don't even need to put that. The A cases are 0, so that is AK is 0 for any key. Oh, no. Right. So all the AKs are 0. So I can now write that my Fourier, of course. You can prove that you can write this at points of and this will be at point of continuity, right? So this will be so you write this, and you can do a similar thing. Obviously, this B and that B are different, but structurally, you can write both of them this way. And you just compute a B case. Okay, so what will be the B case for the first one? So here, for the first one, okay, this is 1, this is 2, right? So in 1, so I will start with the first one. So in 1, the first one, this one. So BK will be what? 2 by. So now you see that here I use 2, right? Who can tell me why I'm using this? Hmm? Who can tell me? But this on the interval 0 pi, you can see here, is 1. So it gives me directly you see that this one is the simplest thing you can ever have. All right. So you get directly right, 2 cosine kx. Okay. Okay, so I was saying that this is the easiest integral you can get. This one, it will be 2 by pi. Of course, there's a negative that will come from here. Negative cosine k pi by k, like this. And that's from 0 to pi. Right. Okay, so we can write it directly. You see that this when the function is expressed this way, really you don't have to stress because your integral becomes easy to compute. So this will be equal to what? So I can take all this, the negative, and the k there. So that's negative 2 by k pi, like this. And now here, I will compute cosine at pi, which is negative 1. No, that's k something. So that would be negative 1 to the k, like this for this one. And at 0 is 1, minus 1. Okay, anyway, so this is what I get. Now, I know that when k is an even number, so this will always be 0. You see? So I can rearrange that. But roughly speaking, this is how easy it becomes. Right. Okay, so you will do the same thing here for G, but you emphasize, what I'm trying to stress on is the fact that this statement, odd function, will imply this. The statement that is an odd function. Because an odd function, if I go back to this one, if f is odd, right, this is our statement, you see that this will be 0. And now our BKs, because this is odd, this is also odd, it becomes even. You have the 2 here. You see, that's why I use this. So you have to be very careful. If you don't do that, if you don't understand the statement, you want to substitute, your A case will not give you 0. Because you will be using something that is different. Because if, for instance, you take f of x, you come and substitute here, it will be wrong. Because your f of x is not an odd function over that interval. This one, 1, over that interval is not. But if you use the structure that is given here, you understand that it's odd, and just use the theorem. So this is an application of the theorem, right? The theorem, that's what I was trying to do here. To apply this theorem when you say f even, f odd. So it can be structurally, or it can also be by construction. And you have to implement and enforce it on your problem before you perform the various expansion. I hope it is clear for everyone. So please go and pursue this. Go and continue, expand this computation for f of x and g of x, right? And tomorrow, Camelo, because he's a dreamer, he doesn't listen to what I'm saying. Camelo, you will give us the result, the solution for this tomorrow. You'll tell me what you get, what your series will be, this expansion, and for g of x. Okay. Thank you for your kind attention. We will stop here for today. Is there any question before I stop? Is there any question? So far, so good. Camelo, tomorrow. Okay, God bless you. See you next time. See you tomorrow. Bye-bye.